Hey everyone, welcome to another day of Algebra 2. Today we're going to do Graphing Standard Form, page 7, lesson 1.04. Make sure you take the next couple seconds now to pause the video and set up your notebook to have the title, page number, lesson, and thinking question space. So now that we've set up our notebooks, let's start with just a little piece of notes before I go into the think aloud. So we're going to write these notes down. We're going to write what standard form looks like, which you already know because you've seen it a million times since Algebra 1. So standard form for a quadratic function is written as f of x equals ax squared plus bx plus c. And we already discussed this in 1.01, where the degree of this function is going to be 2, which means that the highest exponent we see is a 2. And f of x can also be written as y, so just keep that in mind when we're doing our lessons when we see f of x. Great. So now that we have standard form, we know that we have the a, b, and c, the degree is 2. We can go into our first example. So our first example is going to be graph, and a graph. That's why today it's called graphing standard form. Y equals negative x squared minus 3x minus 1. And I'm doing a think aloud, so here's my evaluation steps. And as I go to this think aloud, remember that you are responsible for 2 major things, and those things are writing down everything that I write down, and then listening for and writing down my thinking question. You will be responsible for this thinking question tomorrow in class. So please make sure you have it written down in your notebooks. If you are unable to determine what the thinking question is, text a friend, email somebody, email me, and I can help you figure that out, or write it down tomorrow in class when we go over it. Great, so I'm going to start the think aloud. So I see here that I need to graph y equals negative x squared minus 3x minus 1. How can I use the structure of this equation to reveal my key features in order to graph? How can I use the structure of this equation to reveal my key features in order to graph? Well, I'm looking at the structure of this equation, and I see that it's written in standard form. So I'm just going to write standard form at the top here just to remind myself that this is standard form. And I know that standard form reveals 2 major key features. So I'm going to first identify my a, b, and c value in standard form. This will make it easier for me later when I'm looking at this function. So I know that a is negative 1 because it's in front of x squared, b is negative 3, it's in front of x, and c is negative 1. So now that I have my a, b, and c value, what I'm going to do is take the structure of this function and identify my revealed key features. So these are the key features that I don't have to do any work to find. So identify revealed. I'm going to put KF for key features. And I'm going to write them out over here on the side so that they're nice and neat so I can refer back to them later. So I know the 2 revealed key features in standard form are the direction of the function and the y-intercept. The direction comes from the a value. So looking at this a value, I see that a is less than 0, which means that this is going to be facing down. This will help me later when I'm comparing my final answer to my key features. My y-intercept comes from the c value. So I'm looking at this, my a, b, and c. This c value, the constant in my function, represents my y-intercept. And this a value represents the direction. I'm just going to label that on my equation. And I always write my y-intercept as a point, and I know that all y-intercepts have an x value of 0, so I'm going to write this as 0, negative 1. So now I know my graph is going to be facing down and it has a y-intercept of negative 1. But that's not enough information for me to be able to fully graph this function. So now I have to do my next step, which is to determine my other key features. So now I need to determine other key features. So in order to determine my other key features, I'm going to look at the roots. Because yesterday I learned about graphing in factored form, which means that I have roots. So I'm going to see if I can find the roots. I know I also did the axis of symmetry, and I did the vertex. So I'm going to try to find these same key features in order to graph it in standard form. So to find the roots, I need to be able to factor this. So when I look at roots, When I look at the equation y equals negative x squared minus 3x minus 1, is this factorable? In order to determine if this is factorable, I would need to find, are there two numbers that multiply to positive 1 and add to negative 3? Well, based on the structure of this equation, this is not factorable, because there's no way I can multiply and get negative 1 and add and get negative 3. So I'm not going to find the roots, because they're irrational roots. So irrational. They exist, they may not, but they're irrational, so I'm not going to graph irrational numbers, because that'll be really difficult for me. So I'm just not going to find the roots. So that brings me to my axis of symmetry. So based on the structure of this equation, I'm gonna have to find the axis of symmetry different than how I found it yesterday when it was in factored form. Because I don't have my roots. So I can't add and divide by 2 because I don't have those two numbers. But I can use a formula that I remember, which is x equals the opposite of b over 2a. And this will help me find x value of my vertex because it's the same as the axis of symmetry. So now all I need to do is plug b and a into this formula, which I get from the equation that I identified in part in step 1. So I'm just going to substitute negative 3, so x equals, the opposite of negative 3 is positive 3, over 2 times negative 1, which is going to give me 3 over negative 2. And for graphing purposes, I'm going to write it as negative 1.5. So my axis of symmetry is x equals negative 1.5. That'll just be easier for me to actually plot on my graph. I can use decimals and see those more clearly. And then now I'm going to find the vertex. To do that, I'm simply just going to take my axis of symmetry, my x equals negative 1.5, and I'm going to substitute that into my equation for my vertex. So I'm going to have y equals, because I don't know what y is, but I know what x is, and I'm going to do negative 1.5 squared minus 3 times negative 1.5 minus 1. And remember, this is the axis of symmetry. And now I'm just going to simplify this using GEMDA, so I know I'm going to do the exponent first. So I'm going to get y equals negative 2.25 plus 4.5 minus 1. So I know when I square a negative, it becomes positive. And then a positive times a negative gives me this negative. A negative times a negative is a positive, and then I have that minus 1. So I know these two change, and this one stays the same. Now I'm just going to combine all of these to simplify my final addition and subtraction step, and I get y equals 1.25. So now I can write my vertex. The x value comes from the axis of symmetry, so it's negative 1.5. Those should match. And then 1.25. From my substitution. So great, so now I have a y-intercept, an axis of symmetry, and a vertex. But I still only have 2 points. That's not sufficient to actually finish this function. But I'm just going to take a second and plot these to see what I have so far. So I'm going to go to page 8 in my notebook, 1.04, and I'm going to graph this. I'm going to use pencil to create my x and y axis in case I mess up. So I'm going to create an x and y axis, and I'm going to graph my points. I don't want to take up the whole page, because I don't need the whole page. I just need most of the page, or half the page. Here's my x-axis, here's my y-axis, and I'm going to do my arrows, because I know it goes on forever. Great, now I need to scale my x and y-axis, so when I go back and look at my coordinates, I need to scale it based on what values I have for x and y. So when I look, I have for x 0 and 1.5. So I'm going to use 0.5 as my scale. So my x scale is going to be 0.5. My y scale, based on my points, I have negative 1 and 1.25. So I know that I can use 0.25 for my y scale. So I'm just going to quickly scale that onto my x and y axis. So x is 0.5, so 0.51, 1.52, 2.53, 4, 5, 6. Now I'm just going to skip every other space, knowing that this is 0.5. I'm going to do the same thing on the other side. for my negatives. And then for the y, I'm going to count 4 spaces, and every 4 spaces is going to be 1, because I have 0.25, 0.5, 0.75, 1. 1.25, 1.5, 1.75, 2. 3, 4. I'm going to do the same thing at the bottom. So I'm going to count negative 2.5, 0.25, negative 0.5, negative 0.75, negative 1. 1.25, 1.5, 1.75, negative 2. Great. So now I can actually plot my points. So I'm going to go back real quick, and I'm going to plot these points that I have, which is the y-intercept, 0, negative 1. Which will be right here. I'm going to label that so I can see it clearly. If I don't label, I know that Ms. Pareto is going to take off 1,000,000 points. I'm going to plot my axis of symmetry, which is negative 1.5, which I know if this is negative 1, negative 2, negative 1.5 is right in the middle. I'm going to label it because I know if I don't, Ms. Pareto will take off 1,000,000 points. And then I'm going to plot my vertex, which is negative 1.5, 1.25. So negative 1.5, 1.25, which is going to be right here. When I look at this graph, I can see that I can connect the vertex to this side, and I can start creating the actual shape of my parabola, but only half of it. So here we go. So I see here it's going to be facing down, so I see that I have a maximum for my vertex, because my graph is facing down, so it should be the highest point, because it's going to go down to the y-intercept. But I don't really have the other section of my graph. There's really nothing here for me to connect to, so it's going to be much harder for me to actually plot this. So I need to find the point, the symmetric point to the y-intercept. And this is really useful because I know that every point on a parabola, except for the vertex, has a point on the opposite side of the axis of symmetry that's the same distance to the axis of symmetry. So if I go to the axis of symmetry and count over to the vertex, since my x values are going up by 0.5, I have 0.5, 1, 1.5. So I know this is 1.5 away from the axis of symmetry. So to reflect it over, it needs to be the same distance. So I know I can just go 1.5 the other way. So 0.5, 1, 1.5. And then this, I know, is another point on my parabola. So this would be negative 3, negative 1. And that's my alternate point. And now if I look at this, I can actually construct the other section of my parabola. And I have enough points to make my shape. So now I'm looking at this function and I'm comparing it to what I predicted. It's facing down and has a maximum. The y-intercept is at 0, 1. It has my axis of symmetry labeled, my vertex, and my 2 points have the same y value, have the same distance to the axis of symmetry. And I know I call those my symmetric points. And I can actually write that down just in my key features. My additional point is negative 3, negative 1. Great, and now I have at least 3 points, so I'm able to successfully finish and complete my graphing of my quadratic function in standard form. And we are done. If at any point in this video you felt like you were confused or didn't understand, feel free to come to class with questions. Otherwise, go back and rewatch any parts of this video where you were lost. Thank you, and goodbye.